Hello everyone, welcome to Mezi classes. As you all know that the ATC notification is out, and for that we are bringing a series where we'll discuss the concepts of physics and mathematics in brief details, so that those who already know some of the idea of physics and mathematics of class 11 and 12, they can straight away get to these videos and revise the concepts and then straight away get to solving questions. So in this video, I'll be starting with vectors, because vectors is a topic that is commonly asked in ATC, the mathematics section. So I'll give you a brief idea about vectors, and as we get along, we'll solve some questions as well. But since this is the first video, I'll not get into too many tough questions, because most of the questions will likely involve some other concepts as well that we'll discuss in the upcoming videos. But for now, we'll begin with vectors, and my name is Nirotpal Deka, and let's get started. So the first thing about vectors is that we need to know the definition. So vector is defined as a physical quantity that has both magnitude and direction, and we can contrast this with scalars because they have only magnitude, right? So the important difference between scalar and vectors is in the sense of direction. So if I have to give an example right now, that would be example of speed and velocity. Velocity, as you know, has a magnitude and a certain sense of direction, and speed, as you all know, does not have any direction. A more similar example would be like temperature. Temperature does not have any direction. Like you just say the temperature. What temperature is it? 32 degrees Celsius. You don't say any direction associated with it, right? Similarly with current, if you say what is the current, you say 5 amperes, 2 amps, right? You don't give any sense of direction. So those quantities that do not have a sense of direction, that do not have any particular directionality, we call them as scalars. And something that has both direction, if I ask you like which way is this car going and how fast is it going, we'll say that suppose say it's going north at 5 meters per second. That would be a vector quantity, right? So once we have the definition of vector, we can straight away begin with the types of vectors. So first type of vectors, and probably the most important one, is the unit vector. So as the names suggest, unit vectors have a magnitude of 1 unit. That could be 1 meter, 1 centimeter, depending on the scale you are using. Okay, so any vector, say suppose we represent a vector with a symbol something like that, a, okay, and that geometrically it represents a particular point and an ray. The ray arrow direction gives the direction of the vector, and the length of the arrow, if scaled properly, will give me the magnitude of the vector, right? So when we say magnitude, we mean this one, this quantity. Okay, it's also called the mod of a. All right. So suppose I have a vector a, and if that is a unit vector, what will that imply? I can imply that modulus of a is 1. Okay, whatever be the direction, its magnitude is always 1. And the most common type of unit vectors that you will encounter is the coordinate vectors, right? When you have a coordinate system, say x, y, and z. Now we have 3 directions, right? X direction, y direction, and z direction. Now corresponding to each of these direction, we have a particular unit vector that we represent by I for x-axis, j for y-axis, and k corresponding to z-axis. For shortcut, I'll just say ijk instead of saying I cap, j cap, or k cap. Alright, so these vectors I, j, and k, they are mutually perpendicular, right? Because x, y, z are mutually perpendicular, so I, j, k are also mutually perpendicular. And of course, I equal to j equal to k is equal to 1, because they are unit vectors. By definition, they are equal to 1. Alright, and the other part is that angle between them is 90 degree. These are 2 important things that you want to know. Now what happens, what is the use of these unit vectors, right? So when you have any particular vector, suppose this vector right here, A, okay, now if I give an, suppose it's in the 2 dimension, x and y. Now how do I write this A direction in terms of x and y? So what I will do is that I'll write the components, right? What you will do is that, suppose this part is ax, this part, and this is called ay. So A vector would be something like ax along I cap, right? I have to go ax amount of distance in the I cap direction, and then I have to go ay amount of distance in the j cap direction. I think that's quite clear if you have studied the basics of mathematics at any level of degree or higher secondary. That is clear. All right. Now, if I have to find the magnitude of A, what would I do? I would simply do mod of A is equal to root over ax squared upon plus ay squared. Okay. So if there was 3 dimension, I would write something like ax square plus ay square plus az square, all of this under the square root. Now, the common thing that you will notice is that we often write this thing as theta, right? This angle that the vectors makes with the x-axis. Now what we will write is that, suppose the magnitude of A, I represent this as red color A, right? So ax would be A cos theta. This comes from trigonometry, okay, pure trigonometry. This is a right angle triangle, right? This one is a right angle triangle. So ax would be A cos theta and ay would be A sin theta. So instead of writing ax I cap plus ay j cap, I can simply write A cos theta I cap plus A sin theta j cap. And that is actually useful because in many times we do not know the value of ax, but we know the value of the angle. So it could be useful to write the notation as A cos theta and A sin theta. All right. As we go along, we'll discuss this further, okay, if required. But for now, let's move to the next topic. It's the null vectors. Null vectors, as you can just see by the name, it's a vector that has 0 magnitude, right? So any null vector would have simply a representation of like this, and its magnitude would be equal to 0. All right. So what happens is that, why do you need null vectors? Now remember one thing, that we can add or subtract 2 similar quantities. So I can add like 2 meter per second with 5 meter per second. So that would be around 7 meter per second. But I cannot add 2 meter per second with 5 Newton, right? You cannot add a speed with a force. Speed must be added with a speed. Similarly, vectors can always be added with vectors. They cannot be added with scalars. So suppose I have to add A vector with B vector, then B must be a vector. Otherwise, I cannot do the addition, right? For similar reasons, sometimes I want to add the sense of nothingness, right? 0 vector. When I add a 0 vector, nothing will change, right? To give the sense of the nothingness, we introduce the null vector, nothing else, right? So let's move to the next thing, position vector. Now, again, the name would suggest me the definition. Position means the location of something. Suppose I have an coordinate system, right? So this is the origin. Let me call this the origin, and there is a point R, suppose, and it is located at a coordinate x, y, j. So what I will do is that I will draw a vector from origin to the point, and that vector that will give me the location of that point, that would be called as the position vector. It's usually represented by the small letter r. All right. So r would be something like x I cap, y j cap plus z k cap. In this case only. All right. In some other case, it could mean something else. But anyway, it will give me the position with respect to a certain origin that I have set for myself. Now let's come to the most important part in this summary, that is the dot product and the cross product. Now whenever we want to do a product of 2 vectors, we have to encounter two different ways of doing that. Now suppose I have a vector A, another vector B, then dot product of this is called as A, where A is the magnitude and this is the magnitude of B, and then I have to write the cos theta. Note, when we do two vectors, the dot product of two vectors, we get a scalar quantity. You can clearly see that the right hand side is scalar because there is no sense of direction in the right hand side. This is a magnitude, this is a magnitude, and this is the value of an angle between the two vectors. So if the angle between the two vectors is theta, then what I will do is that, suppose I have vector A here and another vector B here. What I will do is that pull this vector at this point. Alright, what I will do is that pull this vector at one common point. Alright, and if this is the angle theta, this is the angle theta, and I'll use that theta to measure the value of the dot product. A dot B is mod A mod B cos theta. Now suppose you already know the dot product, then how can you find the angle? You'll simply do it this stuff, A dot B divided by mod of A on mod of B is equal to cos of theta. So cos of theta can be obtained if I divide the dot product by the magnitudes of the two vectors. So A dot B upon modulus of A modulus of B gives cosine of the theta, the angle between the two vectors. I think this is clear. Now let's do a simple example using the unit vectors, right? So if I have to do I cap dot j cap, what I will do is that I will use the magnitude of I, magnitude of j, and what's the angle between I and j? 90 degree, right? Because they are perpendicular to each other. Now what is cos 90 degree? Cos 90 degree is 0. So I dot j would be 0 simply. So what we come to know from this is that whenever two vectors are perpendicular to each other, the dot product would be 0 irrespective of their magnitude. In this case, of course, the magnitude of I and j were 1, but even if they were not 1, still they would be 0. So any perpendicular set of vectors would give a dot product of 0. It's quite an important point, because sometimes we want to check whether two vectors are perpendicular to each other. For that checking, you just do the dot product. If it comes out as 0, then it's simply perpendicular to each other. If they're not 0, for example, what I will do is that if let me do I dot I, what will I get? I would get I times I, so basically I square cos of, what's the angle between I and I? 0, right? Cos of 0 is 1. So what I will get is that I square modulus of I is 1, cos of 0 is 1, so I dot I is 1. So basically what I am getting is that when I do dot product with self, I will get the modulus of modulus squared. In this case, the modulus is 1, so we are getting the magnitude as 1. So from this, we'll get couple of formulas in the sense that I dot j is 0, and similarly j dot k, j dot I plus k dot I is equal to 0. This is because this is an orthogonal set of vectors or perpendicular set of vectors. J is perpendicular to k, k is perpendicular to I, and I is perpendicular to j again. So they would give me 0. Now once we are done with the dot product, the simple things comes to our mind that whenever we multiply two vectors, shouldn't we get a vector, right? So that type of product is called as cross product. So if I have two vectors A, and if I do a cross product, I am going to get another vector here. Now what would be that vector? That vector would be A, B, sine theta, n cap. I'll explain to you what is this n cap. Now whenever you have two vectors A and B, that n cap direction would be that direction that is perpendicular to both A and B. Alright. Now what is this theta? Theta is again the angle between A and B, but this time we are using sine of theta. Alright, that's the difference. Again, if you notice that there is a sense of direction in the right hand side. So a cross product gives me a vector, while a dot product gives me a scalar. So if you have two vectors and if somebody asks you to produce a scalar, you used to dot product. And if somebody asks me to do generate a vector out of two vectors, I can do a cross product. I think that's clear. So let me give you the sense of this direction of n cap. How do we find that n cap? Now what you will do is that, suppose I have a vector, let me get this color here, A. Suppose this vector is along this index finger A, and there is another vector. Let me increase the thickness. All right, so there's another vector in this direction. Let me call this B. Now I want to find the cross product of A and B. All right, so what I will do is that point my fingers in the direction of A, or fingers of my right hand in the direction of A, and then curl them towards B. All right, so if when I'll curl them towards B, the thumb will give me the direction of n cap. You can try it for yourself. A cross B, simply point your hand, all the fingers of your hand towards A and curl it towards B. All right, so what I am doing is that pointing my index finger towards A, then I'll curl it towards B, and the direction which my thumb will point will give me the direction of n cap, because n cap is perpendicular to A cross B. Actually, not perpendicular to A cross B, perpendicular to A and B. Now an important result is that when you have I cap cross j cap, what you will get is that modulus of I, modulus of j, sine of, what's the angle between I and j? It's 90 degree, right? And what is the direction perpendicular to both I and j? It's k cap, right? If you take I, you have point your hand towards I, right hand, and then curl this towards j, then your thumb will point towards k cap. It's perpendicular to both I and j. All right, so I and j will give me a cross product of 1 times 1. Not confuse it cross with the cross product. And sine 90 degrees again 1, and k cap is k cap. So I cross j is simply k cap. I hope that's clear. Now note one thing. Last time, if I do A dot B or B dot A, nothing changes. A dot B and equal to B dot A, because anyway, this is a scalar, right? A dot B and B dot A is a scalar. So doing it A dot B or B dot A does not make any difference, because there is no sense of direction in the result. But I cross j is a vector, so there is a sense of direction. So I have to be careful about the order of the vectors, because if I do j cross I would get j times I sine of 90 degree once again, but this time it would be minus k cap. All right, minus k cap, because if you curl starting from j towards I, then the thumb will be pointed in the downward direction. You can check out for yourself. There are a couple of brilliant YouTube videos already showing the direction of the cross product. I will not go into that much details here. So it will be minus k cap, right? So for your easy understanding, let me do this thing, I, j and k. Remember, if you go clockwise, you will get I cross j, k. J cross k, you will get I. K cross j, I. K cross I, you will get j. So if you go clockwise in this direction, it will be positive always. And if you go in the opposite direction, k cross j would be minus I cap, right? If you go in this direction, it would be minus. Remember this trick. So if you go in the clockwise direction, rather anti-clockwise direction, I would say anti-clockwise direction, you would go, you will get a positive sign. So I cross j would give me k, j cross k would give me I. Similarly, k cross I would give me j. However, if I go in the clockwise direction, I would get a minus sign. Remember this. This is the easy way to get across all the stuff. Now simply multiplying unit vectors is not enough. You must also multiply numbers, vectors, like suppose say you have vector A is equal to suppose A1 I cap plus A, let me get the eraser. Yeah, it's A2 j cap. Suppose I have one vector here, another vector B as B is equal to B1 I cap plus B2 k cap. So how do I do a dot product of these two vectors? Suppose I have to do a dot product of these two vectors. How would I do that? I would simply put A1 plus A2. So of course there's I cap j cap dot B1 I cap plus B2 j cap. What I will do is that I dot I is 1, right? But I dot j would give me a 0. So I will not bother even to multiply the terms that have cross terms I dot b. So what I will do is that multiply the I1 term with those with I1 and j term with j. So it will give me A1 B1 plus A2 B2. Quite simple, right? Because anyway, if I take any cross term, suppose I take A1 I cap dot B2 j cap, what I will get? I will simply get A1 B2 I dot j. This would give me what? A1 B2 into 0, because I dot j is 0. We've just found out here. So anyway, the cross terms will nullify themselves. So what I will do is just simply multiply I with I and j with j. This is for the dot product. Okay, remember this is for the dot product. For the cross product, the multiplication would be a little bit more tedious, because they don't cancel out so simply like that. So you have to do the multiplication yourself, and there's a way to do that, and I'll discuss that as we get along. Okay, but for now, let me move on to the next topic. This is the summation of vectors. All right. So large eraser. Let me clear this stuff here. So as I told you, there are physical quantities that can always be summed with themselves. Like vectors can be always summed with vectors. Scalars can always be summed with scalars. That too of a particular type. So you can add two types of speeds, but you cannot add a speed with temperature, right? Similarly, when you add vectors, you have to add similar type of vectors, right? You cannot add a say force vector with a velocity vector. All right, so we have to be careful about that thing. But anyways, if you have two vectors of similar kind, we can do the sum of vectors. How do we do that? This is simple way. Suppose I have a vector A here, another vector B here. What I will do is that bring this vector here at the tip of the arrowhead of the A, so that it looks something like this. A, this is B. Now when I sum them, what I'll get is the resultant. The resultant would be from here to here, and it's A plus B vector. This is also called a triangle law of vector addition. In fact, if you have three vectors, then you will add the third vector here. Suppose I have a third vector C, then the resultant of A plus B and C would be something like this. Let me get another color here. Yeah, something like this. Okay, that would be A plus B plus C. So how many vectors you have does not matter, but what I have to do is that simply get the two vectors in such a way that the tail of one vector is at the arrowhead of the other vector, and we'll finally draw the resultant vector starting from the first vector's tail to the head of the last vector. All right, it's quite simple stuff. And of course, there is a formula for measuring the magnitude as well, but we'll skip that here because it's not very important at this moment. Now, an important point to note is the angle bisectors. Suppose you have two vectors A and B, and they are unit vectors. Suppose the internal bisector of angle between A and B is along A plus B, and the external bisector of angle is along A minus B. Now what does that mean? Now the meaning is simple. Suppose I have a vector here A, remember they are unit vectors, okay, and another vector B. What is the vector that bisects the angle between A and B? That would be A plus B. This is called the internal bisector because it is bisecting the angle between A and B, right? Now what would be the external bisector? External bisector would be along, say this is the external angle, right? That would be A minus B would be something like that. This is the A minus B. This is known as the external bisector because it's bisecting the external angle. All right. So the internal bisector of two unit vectors would be given as A plus B, and the external bisector of the angle is given as A minus B. Okay. Of course, the magnitude could be different depending on what magnitude you want, but for unit vectors A and B, this is the simplest way.